Hello everyone. So in this video, we will solve the problems on the boundary layer thickness. So this is the first problem. So the question is find the displacement thickness delta star, momentum thickness theta, and the energy thickness the delta double star for the velocity distribution given. So here velocity distribution is given with this formula. U upon capital U is equal to Y upon delta. Okay. And we have to find out displacement thickness, momentum thickness, and the energy thickness. So first we should know the formula. So first is the displacement thickness, which is the delta star. So the formula is, you should remember this formula, delta star is equal to integration 0 to delta 1 minus U upon capital U into d1. Okay, so this is the formula for delta star. Now here U upon U, it is already given, it is Y upon delta. So this is 0 to delta in the bracket 1 minus, just put this value, it is Y upon delta into d1. Now integrate this equation with respect to y. So this is equal to integration 0 to delta. So just I will simplify. So it is 1 into dy minus y upon delta into dy. So here delta is a constant. Now integrate this, 1 integration of 1 will be, so it is y minus integration of y will be y square by 2. Delta will remain as it is, and the limit is 0 to delta. Now just put the limit delta and 0. So this is equal to delta minus delta square upon 2 delta. If I put 0, everything will be 0. So this is equal to delta minus delta upon 2. So finally, we get the answer as delta by 2. So this is the displacement thickness. Now the second question is we have to find out the momentum thickness. So the momentum thickness, it is a theta. This is the symbol for momentum thickness. So theta is equal to, this is the standard formula, integration 0 to delta U upon capital U in the bracket 1 minus U upon capital U into d. Okay. Now just put the value of U upon U. So this is integration 0 to delta U upon U, it is given as Y upon delta in bracket 1 minus Y upon delta into dy. Okay. Now just simplify this equation. So integration 0 to delta, just multiply here. So y upon delta into 1. So this is y upon delta minus y upon delta into y upon delta. So this is y square upon delta square into d1. Okay. Now integrate this. So y upon delta, its integration is a y square upon 2 into delta minus y square integration y cube upon 3, and delta square remains as it is, and the limit is 0 to delta. So theta is equal to, now put the limit delta. So this is delta square upon 2 delta minus delta cube upon 3 delta square. And if I put 0, so everything will be 0. Okay. So this is equal to, this delta square and delta. So this is a delta upon 2 minus delta cube upon delta square. This is a delta upon 3. So this is 3. Do the cross multiplication. So this is 3 delta minus 2 delta divided by 3 into 2, 6. So 3 minus 2 delta divided by 6. So this is the value for the momentum thickness. So this is answer for theta. And the last, the question is we have to find out the energy thickness. So energy thickness, it is represented as a delta double star. So the formula is delta double star. This is equal to integration 0 to delta. This is U upon capital U in the bracket 1 minus U square upon capital U square into d1. Okay. So it is similar to the momentum thickness. Just we have to make the square in the bracket U square upon capital U square. Now just put the value of U upon U, which is given in the problem. So 0 to delta, U upon U is Y upon delta in the bracket 1 minus U upon U square. So it is Y square upon delta square into dy. Okay. Now just simplify this bracket. So integration 0 to delta, first Y upon delta minus Y into Y cube upon cube into dy. So delta double star, that is energy thickness, this is equal to, now integrate that. So first y, it is a y square by 2. So y square by 2 into delta minus, this is a y cube. So integration is y raised to 4th divided by 4 delta cube, and the limit, it is 0 to delta. So this is equal to delta square upon 2 delta minus delta 4th divided by 4 delta raised to 4, sorry, delta cube. And if I put 0 limit, everything will be 0. Okay. So here we get delta square upon delta is delta by 2 minus delta raised to 4th upon delta cube. So delta by 4. Okay. So the answer is half minus 1 by 4th. So it is delta upon 4. So this is energy thickness. Okay. So this is how you can solve the problem on the boundary layer. So it is a displacement thickness, momentum thickness, and the energy thickness. Okay, now refer the second example. So here the question is find the displacement thickness delta star, momentum thickness theta, and the energy thickness delta double star, where the velocity distribution is U upon capital U equal to 2 y upon delta minus y upon delta square. Okay. So the formula will remain same for displacement thickness, momentum thickness, and the energy thickness. So first we will find out the displacement thickness, which is the delta star. So the formula is delta star is equal to integration 0 to delta in bracket 1 minus U upon capital U into dy. Okay. Now just put this value as it is and replace this U upon U. So this is equal to integration 0 to delta 1 minus. Now put this complete value is 2 y upon delta minus y upon delta square into dy. Okay. So this is integration 0 to delta 1 minus So this is 2y upon delta. This minus minus plus y. So it is y square upon delta square into dy. Okay. Now integrate this complete equation. So delta star is equal to integration 1 will be y minus integration y will be y square upon 2. So this is 2 y square upon 2 delta plus integration of y square will be y cube upon, and this is delta square, and limit is 0 to delta. Now put the limit. So this is delta minus this 2 will get cancelled. So this is delta square upon delta plus delta cube upon 3 delta square, and if I put 0, everything will be 0. So just simplify this. So this is delta minus delta plus delta cube and delta square. This is the delta upon 3. So this will get cancelled, plus minus. So delta star is equal to delta upon 3. So this is the answer for the displacement thickness. Okay. Now the second question is momentum thickness, that is a theta. Just remember this velocity distribution. So formula for momentum thickness, that is theta is equal to integration 0 to delta u upon capital U in the bracket 1 minus u upon capital U into dy. Okay. Now just put the value of u upon u. So it is integration 0 to delta. We have u upon u. This is 2y upon delta minus y square upon delta square in the bracket 1 minus it is 2y upon delta minus y square upon delta square into dy. Okay. Now simplify this bracket. Integration 0 to delta. Now multiply by this term to the complete bracket. So first we will try to simplify this term. So what we have is 2y upon delta minus y square upon delta square in the first bracket. In the second bracket we have 1 minus, this is 2y upon delta, and this is minus minus plus y square upon delta square into dy. Okay. Now this is integration 0 to delta. I will multiply by this term to this entire bracket. So first is 2y upon delta into 1. So this is 2y upon delta only. Then 2y upon delta. This is first multiplication. This is second multiplication. And this is third multiplication. Okay. So second is minus 4 y square upon delta square. Next we have plus 2y cube upon delta cube. Then multiply by this minus y square upon delta square to each term. So first this multiplication, and this multiplication. So first we have minus y square upon delta square. Next this is minus, so it is plus. So plus, so this is y square and this is y, so it is 2 y cube upon delta cube, and this is minus, this is plus, so it is a minus y raised to 4th divided by delta raised to 4th. okay, into dy. Now we have to integrate this. So first we will try to simplify this. So try to observe the common terms. So this is y square term and this is a y square term. This is a y cube term and this is y cube term. Okay. So after simplification, we will get theta. This is equal to integration 0 to delta. In the bracket, we have first term will remain as it is 2y upon delta minus this is 4y square by delta square and this is y square by delta square. So minus 5y square by delta square. Next, this is 2y cube delta cube and this is 2y cube upon delta cube. So this is equal to plus 4y cube upon delta cube and minus this y raised to fourth upon delta raised to fourth will remain as it is. So into delta, okay, dy. Now we integrate this equation. So after integration, we will have, so I will rewrite this in the next slide. So this is the theta value. Now integrate this. So integration y will be y square by 2. So we have 2y square upon 2 into delta minus integration y square, it is y cube upon 3 into delta square plus y cube integration will be y raised to 4 upon 4 delta cube as it is minus y raised to 4th will be y raised to 5 upon 5 delta raised to 4 and the limit is 0 to delta. Now put the first limit delta. So this 2 we can cancel out. So sorry, delta square upon delta minus 5 by 3 delta cube upon delta square plus 4 will get cancelled. Delta raised to 4 upon delta cube minus delta raised to 5 upon 5 delta raised to 4. So this is equal to delta square upon delta is the delta minus 5 by 3 delta plus delta minus 1 upon 5 into delta. Okay. So this is equal to, try to simplify this equation. So delta, this is the 2 delta minus 5 by 3 delta minus 1 by 5 delta. So this is equal to 2 delta. Do the cross multiplication. So you can take minus common. In the bracket, we have 5 by 3 delta plus 1 by 5 into delta. So theta is equal to 2 delta minus, in the bracket, is 25 plus 3 divided by 15 delta. This is just an cross multiplication. So 2 delta minus, so this is 28 divided by 15 into delta. And this is 30 minus 28 divided by 15 into delta. This is again a cross multiplication. So this is equal to 2 by 15 into delta. So this is the momentum thickness, 2 by 15 into delta. And similarly, you can find out the energy thickness. So for the energy thickness, it is the third question. I will just write the formula to try to solve this energy thickness. Energy thickness is delta double star, which is equal to integration 0 to delta u upon capital U in the bracket 1 minus u square upon u square into d1. Okay. So this is just is similar to the momentum thickness. Now replace this u by u with the given formula, and here u by u square. So we have to square the all the terms. So just I will write here what is the u by u. So this is u upon u. This is equal to, this is 2y upon delta minus y upon delta square. So this is equal to 2y upon delta minus y square upon delta square. Okay. And if you want u upon u square, so u upon u means we have to square this right hand side. So we have to square this. Now we use a minus b square. You can treat this as a, this as a b. So a minus b square is a square. So 2y upon delta square minus 2ab. So 2, a is the 2y upon delta and b is y square upon delta square plus b square. So it is y square delta square square. So y square delta square whole square. So with this we can find out u square by u square. So first is 4y square upon delta square minus 2 is a 4 y cube upon delta cube plus y raised to 4 divided by delta raised to 4. Okay, so this is the value of this term u square by u square. So put this complete equation and replace this value. And for u by u, you can put this directly. Okay, and then try to simplify. So with this, you can find out the energy thickness. So you can expect such type of problem in your final question paper, which is on the displacement thickness, momentum thickness, and the energy thickness.